Hello, my name is Wyatt Rabita, and this is my Physics 2211 Lab 5 report on the Choose Your Own Adventure. Introduction. This lab simulates the motion of a space shuttle launching from the ground of Earth. The purpose of this lab is to find out when the velocity of the shuttle reaches Mach 1, also known as the speed of sound. The fundamental principles used in this lab are Newton's second law and Newton's law of universal gravitation. Newton's second law states the acceleration of an object is dependent on the net force acting upon the object and the mass of the object, while Newton's law of universal gravitation states every particle attracts every other particle in the universe with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between their centers of mass. To simulate the motion of a space shuttle during takeoff with code, certain variables must be defined and updated over time. Using Newton's second law, the position and velocity of the shuttle can be updated over time using the respective update formulas. To calculate the force of gravity, Newton's law of universal gravitation is used in formula. Initial conditions. The system is the space shuttle and the surroundings are Earth and everything else. The mass of the space shuttle is 2,040,000 kilograms. The Earth's mass is 5.97 times 10 to the 24th kilograms. The radius of the Earth is 6,378,137 meters. The initial position and velocity of the shuttle are 0, 0, 0, or at rest. Since all these initial conditions have been found for our system, I have a basis for the computational model in GlowScript. For my calculations, the variables need to be initialized, which is just a fancy way of saying that the initial conditions are being given variables to use in the future. To make the computational model work, the code uses a loop to constantly update different variables until a certain time has been reached. For this model, the goal is to reach the speed of sound, so an if statement checks if the speed is above or equal to 344 meters per second and ends the loop then. First, the force of gravity must be updated. For this model, the space shuttle burns 4,989 kilograms of fuel each second for the thrusters to function. This means that the mass of the rocket changes over time, so the acceleration due to gravity is not a constant 9.8 meters per second squared. After the gravity is updated, the velocity and position are updated with the formulas discussed earlier. Thrust force is a constant 1.47 times 10 to the 7th newtons upwards. The mass of the shuttle is updated with the mass of the fuel burned being subtracted. When the code is run, the shuttle launches from the ground, the velocity of it being displayed every second. When the speed of sound is broken, the code stops, displaying a message telling how long the flight was and how much the fuel was used in kilograms. For this simulation, the trip lasted 59 seconds, and 3 times 10 to the 5th kilograms of fuel were used. Two graphs are also output as results of the code. One graph displays how the velocity increases over time. Velocity does not increase linearly, which shows how the forces acting on the rocket are also changing over time. The force of gravity decreases over time because the mass of the rocket is decreasing as it loses fuel, and the distance between the rocket and Earth is increasing. What about error? Since this lab is comprised of a single computational model with nothing to compare it to determine the effectiveness, there is very low possibility for error. However, there is a possibility that the values for the shuttle's mass, thrust, and fuel loss are off or incorrect. What if question? What if the rocket launched from a different planet, like Mars? Using the mass and radius for Mars, it takes 30 seconds for the shuttle to reach the speed of sound, which is half as long as on Earth. The mass of Mars is about a tenth of Earth's, while the radius of Mars is about half of Earth's. For the simulation on Mars, the trip lasted 30 seconds, which is about half of the Earth simulation. My name is Wyatt Rabita, and that was my Lab 5 report.